All right, time for assignment number 6. Should not be absent, but if you are absent, physically or mentally, hopefully this video should help you get through assignment number 6. Um, if you remember, we talked about there was a difference between speed and velocity in the previous assignments. How speed is just a number, whereas velocity also has speed in a given direction. So there's a number and there's also a direction. So in this class, we talked more about what it means, like how do you represent quantities which have directions. So for example, if I don't know if you guys have ever seen this, but this is called a coordinate axis. And the way we represent this is like the upward direction is positive, the right direction is positive, the downward direction is negative, and this is negative. And the middle section is what we call the origin, or O. So if you're moving to the right, your velocity is positive. If you're moving upwards, your velocity is positive. But you're going left, it's negative. If you're going down, it's negative. And we call this a Cartesian coordinate. So let's just go ahead and write this down in our notes. Cartesian coordinates. What is it Cartesian coordinate exactly? It is a set of two perpendicular axes that helps to represent quantities with direction. So what kind of quantities with the direction? Well, anything that is a vector. For example, displacement, velocity, acceleration, or force. All of these quantities that have direction, they can be represented using the plus minus symbols on a Cartesian coordinate when we're talking about them. And then there are some quantities like, speed, distance, time, mass. These things don't need a Cartesian coordinate to be represented. They don't need a plus or a minus. They're always a number, that's it. And if you remember from our previous stuff, these things are called vectors. Remember, because they have a direction, whereas these things are called scalars because they only have a number, there is no direction to them. That's our little piece of information out there. So let's do an example, right? Let's do an example of this thing. So let's just say, I'm doing an example here. If I say that something is moving with plus 5 meter per second, what does it mean to have this velocity? Anytime I put a plus or negative, that means I'm talking about a velocity. So it means either it's going to the right or it's going up. Let's just say in this case it's going to the right. So it has a velocity of plus 5 meter per second. But if I ask you what's the speed, speed in this case will be just the number. We don't care about the symbol. So 5 meter per second is the speed. Done. Very simple. And similarly, if I tell you that something is moving with 5 meter per second speed in the left direction, and I ask you what's the velocity, well, the velocity is just, we know that left is negative, so it's just going to be minus 5 meter per second. That's the velocity. So velocity will always have a plus or a minus to it, whereas speed is just that number. That's about it. And let's do an example to find acceleration. So we already talked about in the previous video how to find acceleration. If you guys remember, acceleration was change in velocity divided by change in time, which we also said could be written as final velocity minus initial velocity divided by time. V represents the final velocity, and U represents the initial velocity. And one way to remember this is remember that V comes after U in alphabet, right? U, V, W, X. So U is always the initial, V is always the final. And you can use this equation to find acceleration. So for example, let's do the same thing that we did last time. Let's say there's a car, okay, which is moving at, say, 4 meter per second, and it goes to 10 meter per second after a while. and it's moving to the right. It's moving to the right. The first question is, what is the velocity? Is it positive or negative? Well, it's moving to the right, so it has to be positive. So both of them are positive. And let's just say the time it took to go from 4 meter per second to 10 meter per second is 3 seconds. Okay, that's how much time it took. And the question is, what is the acceleration? So look at this equation over here. Acceleration is final velocity minus initial velocity. So the final velocity is just positive 10, which is just 10, minus the initial velocity is 4, so minus 4. Divide that by the time it took, 3 seconds. So 3. 10 minus 4 is 6. That's 6 by 3. That's just 2. Again, meter per second square. Be very careful about the units. That's how much the acceleration is in this case. And if I say, for example, twist this question, so have the same question, the car is going a similar way, but instead of going to the right, it's now started from 10 and it's now going to the left and slowed down to 4 meter per second. So this is now initial and this is final because it's slowing down because it's moving to the left. So it's going in this direction. Again, it took 3 seconds. My question is, what's the acceleration now? Will it change? Well, let's see, right? If I know it's going to the left in both situations, the velocity will be negative for both of them. And this is my final velocity because it's slowing down. So final velocity minus 4, I'm going to put it in a bracket, minus the initial velocity, which was minus 10, divide that by time, which is 3 seconds. And be careful, there's a negative sign. So negative multiplied by negative becomes a positive. So what this is minus 4 plus 10 divided by 3. So you have minus $4 in debt, you only have $10 in your pocket. If you pay your debt, you get $6 left. So that's just 6 divided by 3. And that's again 2 meter per second square. So the acceleration in this case is again positive. And it's 2. The answer is still the same, but in this case the velocities has changed and it's slowing down as well. Cool. So this is how you find acceleration. Use the same equation and that should help you. One of the questions in the assignment asks you about, there is a basketball that is bouncing back. Oops, too big of a basketball. There's a basketball, it bounces off the ground and it's going up. In the question, the ball is bouncing back up. The speed is given to you as 50 meter per second. That's how fast it's bouncing up. And also, so the first question is, what's the velocity? So if it's going up, is it positive or negative? So if the speed is already given to you, the velocity is just you put a positive or negative sign. So think about it, whether it is positive or negative, and put that in. But the next fun question is, it bounces up to a certain height and stops there. So if it stops there, what's the velocity here? Think about it, right? If something is stopped, what's the speed or the velocity? It's gonna be the same, the velocity or speed. Think about what will be that. And the third and the most fun question is, how many seconds did it take for it to come to a stop? And remember, we talked about this. So acceleration in this case is minus 10 meter per second square. So it's downwards. So anytime the acceleration and velocity are in opposite directions, things slow down. Obviously, this basketball is slowing down as it is going up. And it's slowing down the rate of minus 10, which means like it's losing 10 meter per second every second. So it's initially starts with 50, then goes to 40, 30, and the question is still, how many seconds will it take for it to come to 0? So if it starts with 50. Yeah. Think about it, how many seconds will it take for it to come to 0? And that should help you do all the questions on this assignment. And see you in class again.